Hello everyone. In this lecture I'm going to solve an example that includes resistances connected together, but it will be a little bit more complicated to the first two examples we have seen, because now in addition to having resistances we will have a dependent source. So let's take a look at the circuit that we have. We have a 1 amp independent ideal current source that you will see here. We have two resistances, 3 ohms and 6 ohms, that you will see right here. But we also have this, maybe in the beginning it appears confusing, dependent voltage source. So if you look at this voltage source, is actually dependent on a current, which is shown here as I. And if you just scan the circuit to find out exactly where this current is, you will find it right here. So in fact, this is the current that flows inside the 1 amp current source. In more complex circuits we'll see later on in this class, we may have to spend a little bit of time and do some thinking to find out exactly what the controlling variable, I in this case, is equal to. But in this example, things are quite simple in the sense that this current I is directly flowing into an ideal current source. And since I do know the current of that source, I can very quickly find what is the current I. In fact, it doesn't take much thinking to write down that I is equal to negative 1 amps. Since I is equal to negative 1 amps, is again the current that flows opposite to the current of the current source, essentially I now know the voltage that this dependent source is creating in my circuit. I highlighted there with blue the polarity of this voltage source, and 3 times negative 1 essentially will give you negative 3 volts, which is the voltage that this dependent source is creating. So now we know exactly the value of the dependent source. Let's take a more careful look at the circuit. We have to find this voltage V, which is the voltage drop across the resistor with a value of 6 ohms. Now the good thing is that we do know the voltage difference between this red node here and this red node there, which is of course the ground. Now the 3 ohm resistance and the 6 ohm resistance are connected in series. Why? Because the current is exactly the same through both of them. Any current through the 3 ohm resistor must flow and continue through the 6 ohm. That means I am allowed to go ahead and apply voltage division. So if I can apply voltage division, the unknown voltage V that I need to find will be equal to the voltage that I have between the two nodes, which is equal to negative 3 volts, times the resistance that I want, divided by the total amount of resistance, 3 plus 6. So in other words, I have 6 divided there by 9, so that means that this will be equal to negative 2 volts. So this is really not a very difficult circuit, except that when you look at it for the very first time, you might get intimidated because we have never talked about circuits that include both resistances and dependent sources. Before I close this video, I also want to give you a couple of notes for common mistakes I often see in cases like this. One of the most common questions that people are asking me is, how do I combine this dependent source with maybe this resistance, or perhaps with both of them? Well, the answer is you cannot. There is no way to so-called combine a dependent source with a resistance. There is no equivalency, there is no equivalent device that you can write down to replace a dependent source and a resistance. We have learned how you can combine voltage sources when they are connected in series, or current sources when they're connected in parallel, but we have never seen how to combine two dissimilar devices like a resistor and a current source, or a resistor and a voltage source. You can't do that, so don't spend time thinking if there is a way for me to simplify the circuit. There isn't. You have to go step by step. I just demonstrated here to essentially apply some type of a voltage or current division to find the required voltage or current. So don't make the mistake of wasting time trying to think how you could get rid, in a way, of that source, of that dependent voltage source, by somehow combining it with the remaining resistances. So thank you for watching this video. We will see you next time.